Okay, right. You can ignore the first slide there, that was the that's wrong slide. Okay, I'll be talking today about Azure Container Apps. So essentially a solution for hosting your applications on Azure in a not too complicated way. So I'll be starting with just talking about the current options for hosting these sort of things. Then I'll be talking about a couple of things called Kida and Dapper. Then I'll move on to how that relates to Azure Container Apps, and then we'll do a little demo and looking at the code. Hopefully it won't take too long to get through. So basically, we've got a simple problem here. I've got a system. It's got an ASP.NET website, just a normal website, nothing fancy about it, just an MVC API and a bit of HTML and JavaScript in it. And what that has behind it is a background worker process. Now, in our case, that is actually written in Fortran. I kind of chose Fortran because it proved that you can do this with anything. Slight side tangent to that is that my daughter has actually just been accepted onto a PhD course, and because she's a theoretical physicist, she will actually be using Fortran in her PhD. So even though it's now 50 or 60 years old, Fortran is still out there alive and kicking, and this is not a ridiculous situation. This is actually something that she could potentially be using in a year or two's time. We got this standard website and this background worker process in Fortran. And we want to host that. Now, one other thing is that this isn't a terribly busy website, so ideally we'd like to not have it running all the time. Even though it's an MVC website, we'd like to have it, not be paying for it when we're not using it. The current options we've got for this, first one, obviously, we've got this worker process, so the first thing we're going to think about is, some sort of serverless function. And serverless functions are great. They're really cheap and really cost effective. But there are some downsides to serverless. So you have to use something that's supported by your serverless functions. So you have to use .NET or Node or Python or something like that it knows about. Because you have to use specific coding patterns. You have to know how to give it the bindings to whatever it is that's going to be generating the work that your serverless events are going to be running off. And as a general consequence of that, you end up locked into that coding style, so you get locked into that platform. So if you've got something that's written for Azure Functions, you can't pick that up and run off with it to AWS Lambda or something like that. So, particularly for the larger companies where they get a bit touchy about lock-in, there are companies out there that literally just won't listen to the word serverless because of that lock-in thing. So, the other side of the sort of coin here is, of course, containers. Containers, anything can run in a container. Containers can run anywhere, so they can run on Azure, they can run on premises, they can run in AWS, they can run on a Raspberry Pi. And so that brings us naturally to Kubernetes. And that is a real slide. That is the Cloud Native Computing Foundation's slide for the serverless, the Kubernetes landscape. And that bottom left one there is all the people who are out there that they know of that have been approved to come along and help you, because it's too effing difficult to set up a Kubernetes cluster and keep it running. So that's all the consultants who they've decided should be allowed to come in and help you to run your Kubernetes cluster. And given that you've chosen your orchestration and your logging and your observability and all the rest of it from all the little blocks on there, sort of the big blocks I think are the more common ones, and the little blocks are the less common ones. But I'm a developer. I don't care about that. I just want my code to go somewhere and run reliably, and not make me have to think, and not make me have to pay an ops person, and not make me have to get a consultant in. I just want, here's my little ASP.NET website, here's my little Fortran thing, please run them. So up in the top corner there, you can't really see them, but there are a couple of little blocks. One of them's labeled Kida, and one of them's labeled Dapper. And they can come to our rescue in this situation. So KEDA and Dapper. KEDA, first of all, the Kubernetes event-driven autoscaler. Now, what that is for is for doing serverless scaling. So in Kubernetes, you've got what's called the horizontal pod autoscaler, which allows you to run one container, but based on signals to run more than one container. So normally you'll be doing that with CPU and memory usage. So if your container looks too busy, then it will scale it out, and you'll get more instances of that running. What KEDA does is it extends that, so it brings in a whole load of signals that you can use. Generally, the sort of signals that you're going to be used to trigger your serverless workflows. So mostly queues and pub sub things. But it supports not just Azure things, but all sorts of things, RabbitMQ and Mongo collections and all that sort of good stuff. So it can scale based on the size of that, and is in fact, I believe, using pretty much the same logic, if not the same logic, as Azure Functions does. And it also adds an extra little bit to Kubernetes, which allows it to scale down to 0, because the horizontal pod autoscaler will only take you from 1 to n. KEDA will actually turn it off and take it out, so that you can end up with no containers. So the same as normal serverless stuff, you can scale all the way down to 0 and end up not paying if you're using it. So that gives you scaling in Kubernetes. The other thing is a thing called Dapper, which you may have heard of in other contexts as well. It's not exclusive to Kubernetes. It's designed purely for running distributed applications. And what it is essentially, in the Kubernetes terms, it's a sidecar, but you can run it as a process on your machine or in its own container on your machine. So in a dev environment, you can have it running locally without having to have any Kubernetes or even K3s anywhere near it. But what it does is it sits there and it exposes itself on an HTTP port and allows you to call it to do things. And there's a whole load of things it can do there. It can, excuse me. It can do, wrong one. So it can do state stores. So you can plug into it all sorts of state stores. So you can use Redis, or you can use SQL, or any sort of thing which is designed to store distributed state. And all you have to do is to give it some configuration that says what state store you're using and where it is, and then all your application has to do is talk to Dapper and say, save me state, get me state, update me state. You can also do pub subs, so if you want to be working with queues or events or that sort of thing, again, you just tell Dapper whether it's going to be Event Hub or Service Bus or RabbitMQ that's behind that. And all you do is use the little HTTP API to say, send a message, get a message. It actually uses cloud events for that, the cloud events standard as well. So you can, as long as you understand cloud events, you can use that for all your metadata and things. And it also has triggers and bindings, so you can trigger off the same sort of things, and also things like Twilio and Twitter and things like that. And it will save secrets into HashiCorp Vault or into Azure Key Vault or lots of other things. And it's got a few other nice little bits and pieces as well, like it allows you to do an actor pattern. So if your containers are actors, then it will orchestrate your actors for you. Now the nice thing about this is, it means that, first of all, you don't have to pick up the SDK and understand it for whatever it is you're talking to. You can use a simplified API over the top of it. But also, it handles all the sort of funky stuff for you, like retries and connection durability and things. And also, because all your stuff is going through Dapper, it can log all the stuff that you're doing for you, so you get all that automatic observability out of it. It's kind of like a service mesh in that way, but not a service mesh. It doesn't do the routing and stuff, but fortunately, Kubernetes has a thing called Envoy, which will handle that for us. So we've got KEDA for scaling, we've got Dapper for the triggers and bindings that you might have in serverless, and what that comes up with is if we take Azure Kubernetes service and add Dapper and Kida and a little bit of Envoy to it, we end up with Azure Container Apps. But obviously it's not just Azure, it's not just AKS. What they've tried to do with Azure Container Apps is to give us something that's as simple as possible. So in theory, the fact that it's Kubernetes under there is an implementation detail. You can see evidence of it under there, but it is very much to the state of if they had to switch it out to a new service fabric or something else under the covers, they could in theory do that. What you end up with is something that can run any container that can talk HTTP essentially, but with a very simple configuration, at least very simple compared to Kubernetes. You've got all the security and stuff built in. Basically, it's an opinionated implementation of Kubernetes, of AKS. So you get all the security and networking and stuff built in for you. And the nice thing about it is it's fully consumption pricing. So it's like Azure Functions or something in terms that you pay for the amount of CPU and memory that you're using, and you're only paying when it's actually active. But it also has this nice little thing called idle pricing. So as I mentioned, you can scale everything down to 0, and that actually includes websites and things. So if you're willing to wait your website to wake up for about 10 seconds, then you can actually turn your website off when you're not using it and not pay for it. But if you don't want if you don't want it to scale all the way down to 0 and have it always there and always ready to respond, it can still have a much lower, 10% of the actual execution cost as running idle. So if you have it sitting there all the time, it's not like Azure App Service where you're paying £100 a month whether or not you're using it. When you're not using it, it will scale back down. One thing it can't do, one of the reasons everything is HTTP, I think, is so that it can keep an eye on the usage. One thing you can't do with it yet is to take something like Redis and actually, a Redis container and run it within Container Apps, because Redis has its own protocol, its own TCP ports, rather than HTTP. I think they are working on that. We're still in preview with Azure Container Apps at the moment, so I think they are working on getting TCP working, but I think the pricing is essentially why they're having trouble with that, is just making sure that they can keep, exactly measure how much you're using and when things based on non-HTTP traffic. But the final thing about this is, because it only uses stuff that you can install into Kubernetes, if you get to the stage where Container Apps doesn't do something that you want, for instance, if you need something with GPUs and Container Apps doesn't have GPU nodes yet, or if there's just some more complex things that you want to do with it, you can take everything you've got and just lift and shift it essentially into Kubernetes. I'm actually writing a little project at the moment just for fun to actually do that automatically. I would be surprised if other people weren't working on it. I would be surprised, in fact, if the Container Apps team weren't working on something like that, so that at that point at which you decide that you really do need to get the consultants in, that you can do that, and you haven't gone down a blind alley and have to back out in the same way as if you've gone Azure Functions and decided you need to go to Kubernetes or to Lambda, then you would have to back out and start rewriting and reconfiguring. You've just got your containers, your sidecars, and a little bit of whatever it is you use for scaling, which Kida will work in Kubernetes, normal Kubernetes. So I put together a little demo of this. So I have written a tiny little ASP.NET website. I have written a Fortran function, and I've hooked that up to Service Bus and Redis. Like I say, at some point in the future, I hope to actually get all that stuff out of Azure and actually into the Container App, all in the one thing. But for now, because of the HTTP thing, we can't do that. So we're going to fire up some Kubernetes, some Azure services. Everybody understand what it's going to do there? But basically, the ASP.NET website there, when I hit a button on it, it will start firing messages out to, work messages, things to do out to a Service Bus queue. The Fortran, based on Kida and Dapper, will pick up that work, do something. It will update the shared state that is stored in Redis, and it will send the output of that back to the website so we can keep an eye on progress. Okay, everybody got that? Right, so I will show you how that works. So that's my website there. So nothing much going on in the website. We've got an HTML file there which contains. Okay, so yeah, we've got the HTML file in there, which basically just calls through to a couple of APIs in our back end. Down here we have the actual website. So you can see what we've got here. We're going to be sending service bus messages. What we're actually using there is just using the Dapper client. And when we say that we want to send some worker messages, we just take that Dapper client and say, publish an event, please. And we'll see later in the configuration, but we're just saying that the thing we want to send it to the pub sub thing called worker queue. We want to send it to the topic called worker messages, and that's just the message we're sending. Not actually really doing any real work here, so I'm just sending it in the number one as something to do. And then down here we've just got a couple of things to measure the throughput that's going through. So that's your website, which nobody's going to use very much, and that's a simple enough thing. The worker gets a bit more fun. The way the worker actually works, if I have a quick look at the Docker file here, what I'm actually doing is I'm basing this on an Apache-based container. I'm compiling my Fortran into that, and I'm updating my Apache config. So what that actually ends up doing is running my Fortran thing as CGI. So what that's actually doing is when Dapper sort of sees some work coming in there, it will call through to a CGI endpoint that has been set up in Kubernetes. It's not Kubernetes, in Apache, and run this program every time something comes through. So this is the way we used to do it back in the 80s and 90s. So essentially, we're just reading in the input, which we can throw away because we don't actually need it. And I'm literally just shelling out to curl here to actually do the HTTP bit. So even though Fortran has no HTTP stack at all, no networking, it doesn't know the first thing about networking, it can, at least these days, shell out. So I can use curl to go and fetch the value of a counter. I can increment that counter, and then I can use a curl post to send it back out to Dapper and increment that counter. And then the last thing I do here is service invocation, which is one of the other things that Dapper can do. So I say I want to send it through to the web app, and I want to send it through to a method called throughput, and I'm going to post the counter value through. So even though say there's no HTTP going on in Fortran, you can actually kludge it, so you can run anything with that. Anything that can shell out, which I'm not aware of anything that can't shell out. So code clear enough to everybody? Bit of .NET, bit of Fortran, and a bit of CGI, hey presto magic. So when we go to deploy that and actually stick it into a container app, all we're doing a Docker build and push of the website, doing a Docker build and push of the worker. That's going up to just an Azure Container Registry, and then I'm going to do a deploy of this bicep file, so ARM template, infrastructure as code stuff. And this is the whole thing. So ignore the top bits here because we're just this is just the container registry, the service bus, the Redis cache. So that's all the Azure bits. So all we're creating here, we're creating a log analytics workspace for the AKS stroke container app to write to. That bit there is how you can tell it's actually AKS underneath, because when you provision a container app environment, which is basically an AKS cluster, we call it a kube environment. And all we're really doing there is saying, sort of that's the only important bit of that is, that's where our log analytics is. So, not a lot to that. And then we've got two sections down here for the actual apps within, the containers within that container app environment. So we're just telling it which environment we're in, which container we're using, environment variables we can set there, and then this is the scale rule. So this is the bit that's going to use Kida. So we're saying we want to be able to scale the website between 0 and 1 instances. It's an HTTP scale rule, and if we're running behind by more than 100 concurrent requests, then we would scale up. So if we wanted to actually scale up to more than 1, then that's how we'd work out that we were going to need to scale further. And then the data section here just tells me that I'm going to be sitting on port 80. So that's for the service invocation. It knows where to call through to do the invocation from the worker. And then here we're defining a pub sub service bus, and we're using this connection string secret to say where that service bus is. And then down here we've got a couple of little secrets and registry settings, and the thing that says that because it's the website, we want to expose it on port 80. So, that's all we're doing for the web app, and the worker app is very, very similar. This time we're using a queue scaling, so we're using an Azure Service Bus scaler to scale up, and we're going to be able to scale between 0 and 10 in this particular case. And we've got a little bit of information here for configuring the service bus so that you can watch it. And then similar down here, Dapper, there's a couple of components in this case because we've got, as well as our service bus pub sub, which we're going to subscribe to and which will call through to a thing called countering. We've also got our Redis state defined here, and back down here with the configuration. Now you notice we didn't even need to configure the cross-service thing because we've already got names for everything in here, so Container Apps knows that we've got these things and just does that side of things for us in Dapper without us having to worry about it. So very, very simple configuration. Hopefully you'll agree, the ones who've seen Kubernetes, that that's a lot easier than Kubernetes to get this whole thing up and running, with all that extra stuff going on with the pub sub, with the connections and all that good stuff. And if I deploy that, which I did earlier, it will deploy that out. It only takes a couple of minutes to do, and that includes building and deploying the containers to the container registry. And if we're really lucky, it comes up with that lot there. So we've got the container app environment, we've got 2 container apps within it, and then we've got our log analytics and our Redis and our service bus. If I drill down into this, you can see there's really not a lot to the environment. It's all opinionated AKS, so there's not a lot to do in here. So we just know that it's got these apps in here. If I go into the actual worker app, you should be able to see that it's got things set up. So where we've got the ingress set up here is enabled, accepting traffic from anywhere or within the container apps. Because it's AKS, we can actually have it on a VNet as well if we want. So we've got all that good stuff going on. And we can get metrics and logs out of it as well. And the other thing worth mentioning is it's got revisions. So a bit like slots in app service. At the moment I've just got it set to run 1, but you can actually have multiple revisions and have them set to 80% and 20% and whatever percent of the traffic, so that you can do A/B testing or that sort of thing. And having done that, that's our website there. If I hit refresh, it should have scaled down. And if I start sending messages, that should then just go off in the background, and you can see that's now starting to process messages in the background and get them going through. So that cycle we saw there of send message, receive message, update state, send updated counter back to the website is all working. Those throughput numbers are there, just how the difference between the previous value and the new value. Final thing we can show here, hopefully I've done a little bit of a query here. So taking from the container app logs, there's no metric yet for how many instances you've got running, unfortunately, so I've had to do a count of how many container IDs there are mentioned every 10 seconds, but if I run that, you should hopefully see things start to scale up. Yeah, so it's scaled up to 10 there and is staying there. Right, so that was the demo. Everybody clear on what the demo was going on? Any questions about? Okay, so the question there is, given that AKS is under there, can you get at AKS? Can you see what's going on? Get at things. Short answer, no. Like I say, AKS is in theory an implementation detail, so no, you can't hook up Prometheus and Grafana to it and start doing all that sort of stuff. What you can do, it is hooked up to the log analytics there, so anything that comes out of your containers and any metrics that Azure Container Apps chooses to expose, then yes, you can see those, but no, you don't get full access to the pods and things that are underneath it. It is, in theory, its own thing. So, yeah, basically a summary there. It, I think, covers most standard business application things, in terms of nothing too complicated. Just we want to run a bit of web, we want to run a bit of worker, we want to run the normal sort of day-to-day business app stuff. It's got the power of AKS underneath it, but it is a lot easier to use. I managed to set it up by myself without any help at all. It's a hell of a lot cheaper. It's even cheaper than Azure App Service, but it is designed to do the microservices things. It's designed to do the serverless things, so you get to do something like you would do with static web apps or with app service and Azure functions, that sort of thing, but in a much less tied-in way. It's very friendly for DevOps. Everything I've set up there was in a bicep file, so you can very easily deploy it, but you're not locked in. Okay, so there's a couple of links using my custom URL shortener, which I need to do a blog post about how I set that up for one evening. But if you want to get to the documentation and stuff to see exactly what these things support, then that's where you go. And that's everything. So I will take questions or applause. Any further questions apart from is it AKS? Yeah, AKS can go wrong. Now, the theory is that because Azure Container Apps is a fully managed environment, that if something goes wrong in it, then it's not your job to notice. It's not your job to raise the support call. It's their job to notice. It's their job to fix it. So you don't get that thing of please provide me with all your logs and all that stuff. It should, in theory, be more managed, easier, and simpler. Whatever they've got behind that, it is essentially just AKS, Kida, Dapper, and Envoy. There is, some fun stuff happening around security apparently to make sure that everybody's separated out, so that you're not running too close to other people's containers and able to jump across. Which, that never happens in Azure anyway. Obviously, never seen that sort of thing happen recently. Yeah. Mm-hmm. So basically, AKS is, or Kubernetes is very heavyweight and expensive to run, even locally. So you end up running K3S or whatever and hoping it's similar. There's not a brilliant local dev story for Azure Container Apps just yet, but as I said, Kida you don't really need, because when you're doing local dev, you're probably only running one instance anyway. Dapper will run locally just as a process, and your containers can just run normally in Docker, as Docker Compose as you would normally run them. So again, I'm hoping before it comes out of preview that there'll be a more together story around that. But yeah, you can run it all locally, just on your desktop or on your PC. Are you talking about running, running it in, sort of that in Azure or just locally? Yeah, for a dev team working together, there's no reason why you can't run it straight into container apps, in a dev environment, because like I say, it's consumption-based pricing. It's not like AKS where you're paying for a node as soon as you've got the node. So yeah, you can run a dev environment. It will only charge you for when you're using it. You won't get charged overnight when nobody's there. So you should be able to do that, and you can do that same sort of thing locally as well. Did you have a question as well? How long does it take to scale out a new container? If I do a cold, when I've seen the website do a cold start, it takes about 5 to 10 seconds to get to actually responding. In terms of how quickly it scales out, there are parameters that you can give to Kida to tell it how aggressively it should scale. So like in that HTTP one, there was that concurrent request thing that said, if I'm 100 requests, if I've got 100 outstanding requests, then I am too busy and you should fire up another container to get going. And Kida's intelligent enough to say, okay, well, if you've got 500, then I'll fire five of those up now rather than just doing one at a time and trying that. And the same sort of thing applies to service bus queues as well. You can tell it how aggressively to monitor that. Yeah, like I said, Kida is, I believe, it's not exactly what they're using in Azure Functions, but I think a lot of the code is shared. So it's using the learnings from Azure Functions. So. Okay, any more questions? Right, that is everything. Thank you for coming back to the first in-person Azure event for 2 years. I hope we'll manage to do another one and that we won't get any more variants that put the kibosh on it. And thank you very much. Do feel free to hang around and have a chat, or come and ask me questions afterwards. There's probably pizza left if you want to take it away and have it for lunch tomorrow. Otherwise, thank you very much for coming.